react to action. So Connor and Sam both built versions of this framework, but they also built it with 3 core tools: searching the internet, searching the website, and scraping the website. So you can see here on the left, we have Sandbox Mark 1 and Connor agent. We named all the agents here. And you can see the differences in the architecture. The key differences here is that Sam chooses to use a weaker and faster model 4.0 for generating plan and pricing plan. And Connor chose to use the reasoning model at the time and to generate a stronger plan and report it. And then we both need to this agentic tool use. After we built those, the first thing we want to know is how do we know which one is better? So before we build any evals or any metrics, we spend a lot of time looking at the traces to see and the directories to see, okay, which one is working better. And what we found initially is that O1 produced much more thorough research plans. So you can see here on the left, we have O1 preview, and on the right, we have 4.0. You can see O1 preview, O1 preview, same prompt, and for O1 preview, we have around 1,600 tokens, and only 600 for 4.0. If you want to zoom in for this plan, you can see for a specific question, all the questions in the prompt, the difference in quality and specificity about the 4.0 preview versus 4.0. So you can see we've outlined how to answer the question in O1, percentage of mistakes, false in O1, and also even the value type, the structure output that was provided. And so what we found actually from this plan is that this increase in specificity and actually general verbosity help the agent improve outcomes downstream of this initial planning phase. But after we did this kind of vibe check, we started to build actual evals. So we started with just accuracy, which was just a percentage of questions answered correctly, and then hand labeled a bunch of data sets. So I actually hand labeled probably 500 examples across 100 companies for each of these 5 data sets. And take these data sets we install what we call customers at the time of use our agent. So things like this phone user, B2C, phonographic, technographics, so that we can deploy these agents and actually get into those questions. And we hit Connor agent and Sandbox Mark 1 head to head, and you can see the Connor agent came out on top. It kind of beat out Sandbox in most categories, and the margin was pretty significant for these tasks. So what we learned from these initial developments. So like I mentioned earlier, these reasoning models have an outsized impact on downstream actions and downstream accuracy. And then we also do the accuracy-based evaluations were a good heuristic for how good of an agent is doing. But between that and actually still having to look at the traces, we have clear insights into where to go from here. So we know these are the metrics these agents produce, but how do we work with the agents? And so we thought about 3 core axes for how we improve these agents. One is like changing the graph and architecture, 2 is changing models in the prompts, and then 3 is adding more tools. So we spent a lot of time reflecting on customer use cases, customer needs at the time. We wanted to enable like a lot of these initial workflows with these changes. So changing models and prompts, so now is the first 2 areas we wanted to invest in for improvements. So I'll talk a little bit about a couple of the cool learnings we have from doing model and prompt changes. So first thing we want to do is kind of optimize for performance and cost. O1, O3, and O1 are pretty expensive, and they're also pretty slow. So, and also at the start of this year, there seemingly new models are coming out like week after week. So you're often just plugging in a new model trying to see if it's better or not. And what was interesting is that we didn't really see a huge difference until 4.1 came out recently, and that's the only model we replaced O1 with in production for agentic planning. And the outcome of this change is that initial agent run that used to cost around 35 cents now costs around 10 cents for one with similar performance. You can see here the number of other models we tried and why O1 is the best or most cost-effective model for planning in our agent. And we tried even DeepSeek, 12.7, and Gemini 2.5 recently. And one thing that I guess for DeepSeek was that when it came out, it was really promising, but it was only until probably like a week or 2 ago when latency was down to an acceptable threshold or similar to like O1 for these tasks. Another thing we came across was date formatting, which is pretty interesting, where we had a bunch of models fail to correctly identify what date was in the future just because of the formatting it was in. So we saw that full row struggled with something like 5/14/2025 versus May 15/2024. Because the date was in the future, it actually thought that the date of 2024 was in the future as well. So we've done some adjustments in prompting just by providing actually different versions of the date to improve the performance and standardizing accuracy on a date-based task across models. The last big thing was how do we improve tool calling? This is something we're still working on, but initially the huge problem was that agents were making throwaway tool calls. Something like searching for BB, just generally. So what we did is we ended up changing a lot of the predictive models for these input schemas or tools to force the tool calling node or tool calling agent to change the input schema and think a little bit more about what it was calling. So just overall across prompt and model changes, we learned that agent costs are going down a lot because we're able to swap O1 and O1 for agentic planning with no notable quality change. And also we learned a ton of edge cases that evals don't necessarily cache. And even if you build a lot of robust evals, you're probably still going to find yourself looking at the traces with some kind of human eval or human vibe check. And that's even notable from OpenAI recently with their changes in the models and ChatGPT. We also learned models tend to spike in different use cases. So using a model in planning might not be as effective in tool calling or reflecting some different parts of your agent workflow. So you probably want to do some kind of interface schema. So the second axis was building more tools. And we did think about what tools we need to build, and so we thought about what use cases can we not today that we really wanted to turn on with tools. So customers can empower more workflows with by adding just a single use tool. So the 4 tools we decided to add most of this were internet research, browser access, searching HTML, and dataset access. So I'll go through a couple of these. So why we started with deep internet research is that internet search is still hard. Between SEO articles on Google and as well as with search grounding LLMs with things like OpenAI and complexity, you're left with a lot of result quality is out of your hands. And we also saw that in our agentic use that tools or calls to the internet were not being utilized like we would. So like this is how we conduct research on the internet before using LLMs. So we thought about how do we do it today. So we're pretty good at doing internet research, but we do it fundamentally differently than agents are doing it, or how our agents are doing it initially. When you do a search on Google, you might search for a query with the top 10 links, implicitly filter out probably 5 of those just based on the source, open a couple of new tabs, maybe read through a couple of sentences on each before deciding that you need to do a different search query or that you found your answer. So we saw that our agents were not mimicking this common behavior and wanted to adjust course to improve agent result quality. So we upgraded from our initial identity model, which was initially we had a very naive structure, which is just kind of a query term. We kind of flipped that to include a bunch of other arguments with things like a category, whether you want a live crawl, including the text in the summary, and also like maybe constraint one domain or you can publish that date. And so by changing all these parameters, we're changing the trajectory of Google search as well. From first reviewing just the preview from an internet search output, which is what we have on the left here, to after getting both the URL and the actual page content in one tool call. So what this allows us to do is pull in all this content at once and sidestep this issue that we were seeing with agents picking an answer just based on the Google search preview, which as we know isn't always reliable or accurate. So the second main tool we built was browser access. So how do we do it again? There's a lot of rich data online that scraping isn't able to capture. So between like online data sources or data sets that require you to enter a query, interactive search experience, or even things like Google Maps or images, you can't really capture that content with scraping. So we wanted to allow our unified agent to use the browser the same way we would. So we built browser access as a sub-agent. So we gave this tool, which is basically browser access to this agent, and what it does is it decomposes the task into a browser trajectory using Portfolio Many, and then also uses computer use preview to actually action on that. We evaluated browser use, the open source alternative, and we found that while it was marginally faster, it struggled in more complex browser tasks, which led us to use computer use preview instead. You can see an example of this here is where we try to find if Google has EV parking on site. And so it eventually ends up using the browser use tool. It goes to Google Maps. It ends up using Street View, going through, looking for an EV charging station in their parking lot, and then also flipping to a new tab in the browser to check to see if it has EV. And on that last page there, it does actually confirm between Google Maps and that page that there is an EV charging station. So we learned a lot from these tools, and one thing we learned is, okay, we can't use this kind of naive approach to internet search. Internet search and Google is great, but you still need to empower your agent to be able to look at the data, ingest the right content into context, and then action based off of that context. Deep search and this pivot to changing and pulling in content at once massively reduced the amount of misinterpretation we have in internet search and changed how we do research. And these other tools like browser use and searching HTML unlock completely new use cases for our agent. So as a result, the new agent and the new champion we have in product is Canal Browser Agent. As you can see, we still kept the name or theme of naming our agents. So a couple quick next steps is based on these changes in tools, we want to invest a little bit more time in evals to actually highlight some of these issues that I found, just looking through traces that we found, looking at outputs, to make this process a little more repeatable and scalable.
Awesome. We're solving a lot of interesting agent problems. So if you also want your name in our code base as an agent, come chat with us after or apply online. We are hiring tons of engineers. Thank you guys.
So next up is Eno Reyes, founder and CTO of Factory. Eno will be sharing insights on challenges with agentic systems and how Factory is tackling them with LangChain. Please welcome Eno.
Hey everybody, my name is Eno, co-founder and CTO of a company called Factory. At Factory, we believe that the way we build software is radically changing. We are transitioning from the era of human-driven software development to agent-driven software development. You can see glimpses of that today. However, it seems